Okay, so how am I going to separate out the blue and red ink? Well, first step, I'm going to prepare a beaker. This is the beaker. The next step is I need to have a solvent. Right, this is the solvent. We often use solvents like, sometimes you'll find your textbook, we use solvents like ethanol. Ethanol is a particular kind of alcohol. Sometimes we use water in the laboratory. That's cheaper, easier to use, easier to access from the tap. Alright, basically we need a solvent. Okay, so how are we going to separate out the red ink and the blue ink from the purple droplet of water? One of the first things you need to do is to first draw a pencil line on the filter paper. I forgot to say that this piece of paper I've drawn here is a filter paper. Okay, we're not quite using the filter paper for the same purposes as in filtration. This filter paper is more for the purpose of absorbing the solvent, right? This paper's purpose is to absorb the solvent, not so much to do any filtering. Okay, all right, so back to the start. I've drawn a pencil line here. Okay, the reason why we want to draw this pencil line in pencil is because pencil does not dissolve in the solvent, so it will remain there even if I submerge it in the solvent. We call this line that I've drawn over here the start line, because this is the point, this is the line where I'm going to introduce the dot, the ink droplet. So right now I'm going to introduce the ink droplet. I'm going to introduce the purple ink droplet over here. Usually what we do is that we introduce several drops of the ink that we want to separate. Why several drops? So that I can make sure I have a lot of ink on the spot. What's going to happen next is that we're going to submerge the filter paper. Okay, I'm going to see if I can submerge the filter paper. Okay, I'm going to submerge the filter paper into the solvent. Okay, here we go. I'm submerging it into the solvent. Now, after I've submerged it into the solvent, the filter paper will start to absorb the ink, the solvent, right? The solvent will begin to be absorbed by the filter paper. Okay, it will begin to be absorbed. I'm going to now represent the movement of the solvent up the filter paper with a blue line, right? So here's another blue line, shows that the solvent is being absorbed by the filter paper. Here's another blue line, it's being absorbed a little bit more. Okay, and now the solvent has reached the level of the ink droplet. When it's met the ink droplet, this is when the ink will begin to dissolve in the solvent. Now, something very interesting happens when the solvent starts to go and rise higher beyond the ink droplet. Okay, it starts to rise beyond the level of the ink droplet. Let me just erase away all the previous lines so that you're not so distracted. Okay, now this is the new line. Okay, this is the new line that I've drawn here. Okay, so I'm going to refer to this line over here as the solvent front. Solvent front. Solvent front refers to the furthest point that the solvent has moved up the filter paper. Okay, so this is the solvent front. When the solvent front has moved past the ink droplet, the ink particles will dissolve in the solvent and they'll begin to move. Okay, and this is where the interesting thing is. Substances that are more soluble in the solvent compared to substances that are less soluble in the solvent. Substances that are more soluble in the solvent will be able to move faster up the filter paper along with the solvent. And this makes a lot of sense actually if you think about it, because the blue ink has intermingled with the water molecules. They mingle together very well. See, they're mingling together very well. And because they mingle together very well, it will be able to travel along with the solvent up the filter paper much faster. Okay, so I'm going to draw in the blue ink. Okay, now the blue ink is beginning to separate from the solvent. Okay, this is a blue ink droplet. The blue ink has separated from the purple. It's separated much faster because it's more soluble. Because the blue ink molecules are intermingling with the water molecules very well, so it's traveling along with it much faster. The red ink, however, is probably still within the purple ink droplet. And the red ink is still within there. It's not so soluble. It's not intermingling with the water molecules that well. It's not that well. And therefore, it doesn't travel with the solvent as fast. Okay, so let's continue on the story. Okay, so the solvent front is going to move a little bit more. Okay, the solvent front is moving up. And as the solvent front moves up, the more soluble substance will continue to move fast along with it. Eventually, the less soluble substance, let's see if I can just get out the red ink molecule. Okay, maybe not. Okay, eventually you'll find that the red ink droplet will start to emerge, right? The red ink droplet will begin to emerge. It is less soluble, and so it takes much longer for it to begin to travel up the filter paper. Eventually it begins to emerge. Okay, let's see a little bit more as time passes. The solvent front moves furthermore as the filter paper absorbs the solvent. The more soluble substance will travel along with it much faster. The less soluble substance will travel slower behind it, right? And this will continue on. But you see, as this happens, I'm separating the two ink droplets. The two ink droplets have been separated out. And they've been separated out because they have a difference in solubility. One is more soluble, the blue ink droplet. One is less soluble, the red ink droplet. Because they have difference in solubility, okay, the key word here is difference in solubility, they separate out when I carry out chromatography. That's the beauty of it. Okay, let's see if I can continue. Okay, so eventually the solvent front will move up further. The blue ink will also move along with it, along with the red ink. But the red ink will always be lagging behind because it's less soluble. But eventually, okay, so this kind of experiment, you must stop it after a while. You must take the entire filter paper out of the solvent. Okay, let's see if I can take it out of the solvent. Okay, I must take it out of the solvent. Okay, oops, the edge of the paper didn't come along with it. I have to take it out of the solvent because I don't want this solvent front to keep moving up. If I continue leaving it in the solvent, eventually this is going to travel up, right? And then this ink droplet will move to the edge, and eventually even this red droplet will move all the way to the edge if you give enough time, and then it will merge together to form a purple drop again. That's not what we want. Okay, so that's why you must take out your filter paper from the solvent eventually. You cannot leave it inside for too long. Okay, but now it's beautiful. I've separated out the red and blue.